Welcome to our little lunch and learn. Some housekeeping before we go on. You'll probably be able to see that this is being recorded. Afterwards, we'll send a copy or a link to the webinar to your email. No one can see your face, obviously, but if you have a problem with it being recorded, then we'd ask you to leave now. But hopefully it shouldn't be a drama for everyone. As I've said before, 20 minutes probably of Matt and I sharing some things. The aim of today is we don't want to just talk about stuff you already know. So we will get through some basics about cold spray and SPEE3D, and then we're going to try and get onto some new stuff and tell you some news, and then we'll have a Q&A session. So 20 minutes of us talking, sharing some things, and then 10 minutes Q&A. If we run over 30 minutes, it's not a drama. I'd ask you to mute yourself just now as we're doing the presentation, and then we can chat during Q&A. Yes, so let's do introductions. Obviously, most of you, I think, are calling in from the United States, less Coyote in Nigeria. I'm based in the UK, and I've been with SPEE3D for 4 years. Before that, I was in the Australian Army as a maintenance officer for 3 years, and I was before that 10 years in the British Army as a maintenance officer. But it was during my time with the Australian Army that I started working with SPEE3D. So that was a collaboration between Australian Army and SPEE3D to explore the boundaries and possibilities of deployable, digitized manufacturing in defense. If we had the technology, would a commander want to be able to manufacture equipment for themselves so that they can get more kit in the fight more of the time? But does the technology exist and can it keep up? That was the purpose of the Australian trial. As a result, SPEE3D built its defence proposition, and here we are 4 years later. I'm back in the UK where I lead the programmes, the defence programmes across EMEA. And every so often I like to post images or videos on LinkedIn, printing in the rain. That's me. I'll let Matt introduce himself.
Hey, you bet. Good morning, good afternoon, wherever you're coming in from. My name is Matt Ort. Coming on 2 years with the company now. I retired from the Navy 2 years ago after 25 years. I was a pilot by trade. And then for my last 3 years, I was a U.S. Naval Attaché to Australia. And during that time, the ambassador had come to me during COVID and asked me to go out and find some Australian technology that would help disrupt the supply chain issues that we were currently experiencing. And so I found SPEE3D, and you know, obviously it was a good fit for me, and it was a killer tech, and that's exactly what they do, is disrupt the technology. So let's get going, Calum.
Yeah. Those photos might make you think that Matt and I are similar height. It's just not the case.
I actually was wearing 10-inch lifts in that photo.
Yeah. All right, Joe, let's move to the next slide. Okay, so very briefly, we'll talk about SPEE3D. So a Melbourne-based business, so founded in Australia 10 years ago now, okay, by Byron Kennedy and Stephen Camilleri. Melbourne is the headquarters, and in Darwin, which is basically the 12 o'clock point of Australia, in the outback, basically, is our R&D centre. So 2 offices in Australia 10 years ago. Byron and Stephen's intention was to create a new and disruptive manufacturing capability, a new way of making metal. They had previously created technology, high efficiency electric motors. They had sold that business, set up manufacturing facilities for it. It was during that time they experienced metal castings, what it is to make metal in the world. And from that experience, harrowing experience for them, they decided they wanted to make their way of making metal. They wanted to make it cheaper, more efficient, more reliable, automated, digital, just better. They chose cold spray as their way of doing that. Cold spray is a history going back somewhat 60 years, first invented by the Russians. And we'll talk about what that is in the next slide. But for now, that was 10 years ago. And they designed their prototypes in their garages. They sold their first printer some 5-6 years back now. and they've grown the business ever since. And now we have offices in the United States, UK, Germany, and Australia. We have printers all around the world, but when it comes to defence, we have printers with the British Army, US DoD, Ukrainian Armed Forces, the Japanese Ground Self-Defense Force, the Australian Navy, Army, Special Forces. And later this year, our next defence customer is a particular country, MOD in the Middle East. The technology, as you can see, with XSPEED behind me in my image here on the slide, that's our expeditionary cold spray printer. We'll talk about cold spray in a minute. That's the latest of our printers. It's a shipping container. You can pick it up, move it around the world, connect it to electricity, and we're up and going, and we are able to make large metal parts fast. And there's some images there, obviously, of some of the parts the printer can make to give you an idea. We can go on to the next slide. Right, so cold spray additive manufacturing, CSAM, or just cold spray. The image you can see there at the bottom, you can see the nozzle pointing upwards from the ground. It's firing out a mixture of metal powder and compressed air. That image is actually titanium. Titanium gives us that lovely glow. So we have our nozzle pointing upwards. We've mixed high pressure air, 30 bar is the pressure that we initiate with, mixing it with metal powder, heating it through the system so that when it comes out the end of that metal barrel, it's moving at roughly Mach 3. Move that metal really fast, so long as the metal powder is the right particle shape, particle size distribution, right shape, right size, right hardness, so the right metal powder. We move it at the right speed. We know it's going to deposit on impact. And we have a really high deposition rate. We're talking 90, 95% plus, depending on the metal. So when it deposits, if we just kept depositing, we'd get a great big metal slug. But with our software, which is the real secret sauce of SPEE3D, with our software, we now control this plate above, such that as the metal powder deposit, we're able to manipulate the substrate and we build a plate reverse, so from the top down. Okay, so you're taking your CAD file, you're drawing on Fusion or SolidWorks, whatever it may be. We run it through our system, TwinSpeed. TwinSpeed will create not only the print file for you, but a full digital simulation to show you where your design will succeed or fail. So if you've designed it out with the parameters of the printer, you're not printing something and experiencing failure during the print, but rather every time you print, you're getting a successful print. So our software creates that instruction, place the file in the printer, and off you go. Electricity, powder, the digital file, and we're making parts. Slamming that metal powder, Mach 3, controlling the substrate to build parts. 6-axis robot arm, it's an ABB robot that we've got in our systems at the moment. Okay, and now you're making your fully dense metal parts. The parts, when we print, are like coffee cups. Okay, they're strong, but they're slightly brittle. Thereafter, we get onto the post-processing that's required to make the fully hardened parts that you would want. Okay, but when you take a part out the printer, it's solid metal, right? It's not something that's going to crumble in your hands. Indeed, you don't need to heat treat. If you design a part and print a part, when it comes off, it's solid metal. And in many instances, my team, and our customers print parts and just use parts. So heat treatment isn't always an absolute necessary. That's the CSAM process, our automated CSAM process. But before we move on, Matt, if there's anything I've missed, give us a shout. Otherwise, we can move on.
No, well, let's keep moving on to some of the CSAM advantages.
All right, let's move on to your slides.
So there's several key advantages that the CSAM has over some other solutions that are out there. And one of it is fast prep and build speeds. And we just kind of encountered that for the first time in the field with my first time in the field with the XSPEED. where they dropped it off on the ground in Hawaii, not even ground. We used some shims, got it all level, and plugged it into some power. And in a matter of hours, you're slinging metal at up to 13 pounds an hour, depending on the material you're using. And then you can build large parts, right? You're talking about a meter, 40 inches by 40 inches, or, and then up to about 90 pounds, whichever kind of comes first. But that's a big part, and, builds pretty fast at 13 pounds per hour. Material changeover is another advantage. I know a lot of the other solutions, could take, days to change the material out. Here, an experienced crew can have it changed out and running in, probably 30 to 45 minutes, and a brand new crew is doing it in an hour and a half. The system's really easy to operate. We just trained some reservists with a ground school, and then a couple hours of on-hand operation, and they were printing parts in a couple hours on the second day. And I think most of our installs, after 3 or 4 days of training, you're printing parts. And then it's safe, right? There's no lasers, there's no noble gases, you're not changing state. The build happens inside a sealed off area, and it's very safe to operate. And so you're producing high density, low porosity parts with a lot of different materials, and we're coming up with more. And then if you've got on-site post-processing, or you've got our speed cell, then you're post-processing and heat treating the parts right on site, and you've eliminated your supply chain. Calum, why don't you tell them about your last exercise here?
Yeah, we in a little bit we'll talk about exercise Steadfast Defender and the big NATO exercise that's happening in Europe. If we just go back one slide, Julie, if we go back, please. I was with the British soldiers that have had this equipment now for effectively, really, they've had their hands on it for 6 weeks. And as part of our partnership with them, we go and support them. We're coaching them for the next 2 years to make them advanced manufacturers. And that printer, the XSpeed behind me, was out in the rain in Belgium printing parts. Even in the rain, the soldiers were changing powders. The system's designed that actually they could be changing small amounts of powder without exposing themselves or the powder to the rain, and changing powder in about half an hour. It was incredible to see. People were just stood around watching, amazed at the gall of these soldiers daring to change their powder in the rain and then continue printing. It's, like I said, digital file, electricity, powder, and you're off. This thing falls off the back of a truck. We place it on the ground from the back of a truck. Let's say half an hour to 45 minutes, you're up and printing. And it's just a case of plugging the electricity, heating up the system, and off you go. So it's a robust system. It's mechanical, there's no lasers. And we've designed it such that that nozzle is rock solid. Very rarely are you having to worry about the calibration of the nozzle. So yeah, it's fast, it's robust, and we've made it deliberately as simple as possible, particularly for the deployed soldier, so that they don't have to worry about, is my printer going to work, but rather, how many parts can I make and how quickly can I make? Let's move on, Julie. Next slide, please. Was this me or you, Matt? Which one? Would you like to take?
One more. I went through that one.
Okay. Yeah, so linotyper. On the left here is an image. It's an image, Belgian Defense Minister. This was AM Village. So on the left is an image of AM Village held in Belgium last week. AM Village is, the EU has an arm called the European Defence Agency. Now, the European Defence Agency doesn't have any soldiers. It is not a military, it's not an army or a navy, but rather it's an organisation that has billions of euros to develop defence for EU nations. And some of that money goes towards advancing manufacturing, deployable digital manufacturing for defence. And each year we come together where the nations come together in a collaborative effort to share best practice, to learn from vendors, learn from each other, display with the recent developments. Now, the UK, we will all know, is not part of the EU, but actually they're doing very well. They're leading the charge somewhat in Europe. So they're invited along to this event, as were SPEE3D. And you turn up to this event, there's maybe 25 other nations there. The equipment's on the ground. British soldiers are using their equipment. And the plan for the week was, as I said, to share and to collaborate. But we had good friends from the armed forces of Ukraine at the event as well. And their challenge was, here are 77 parts that we need. Parts that we need for our platforms, and they laid them out on a table. Please make as many of them as you can, with the idea being, make the technical data package that they can take back with them to Ukraine so they can make these parts.
Hey, Calum, were all those parts the same material, or were there different materials in those parts?
There was a whole range of materials. There were plastic parts, metal parts, big parts, small parts. And so all the vendors there, including SPEE3D, we take on the challenge. Now, you might be aware, SPEE3D have a lot of equipment in Ukraine. Okay, so there are 9 printers. This is open source. There are 9 printers. Warp Speeds, the ones behind Matt, 9 of those in Ukraine. So for us, it wasn't too difficult, nor was it too difficult for the Ukrainians to get our minds around some of these parts that they brought. And in the space of 3 days, we ended up designing, printing, heat treating, and cutting 6 parts. 6 parts with our system, 6 technical data packages. And the remarkable thing was watching people, there's a bit of courage involved in this, okay? Printing the part in the rain, a lot of people are a little bit surprised and that people would be audacious enough to do that. To then heat treat the part. Speed cell is the white container, if you see on the left there, to take your metal part and stick it in an oven to 1200 degrees in the field. To then bring it out on a set of tongs and quench it in water, because that's the heat treatment process.
To be fair, Calum, that rain that you're talking about in Europe there seemed like almost a drizzle. I think we did it in like monsoon conditions in Hawaii. So, like we're talking, 100 mils for you. That'd be 4 inches in freedom units in a day.
It can handle a lot of rain. And then you've got these glowing red hot parts coming out of the oven, and we're quenching them. And then we're machining them as well, to then say, and to see people's eyes when the full metal part comes out. I wish I could show you. I'm simply not allowed to show you. Here is your replacement part. Now, these are battle damage repair parts. Okay, these are parts that are made to get the soldier back in the fight and the platform back to the battle. It's a whole other ballgame if we're talking about the industrial base. But having deployable digitized manufacturing, optimized for the soldier, so we can get those metal parts out and back in the fight. We did 6 parts. So as one entity, British Army, SPEE3D, we did the most number of parts, because we were literally doing 1 part every 4 or 5 hours. It was a really exciting event to be part of. On the right-hand side is the same equipment. It's still in Europe, and it's part of Steadfast Defender, that being NATO's largest deployment across Europe since the Second World War. Forces from the beaches of Normandy stretched all the way across to the border with Russia, up and down that border from Finland, all the way down to Poland and through Poland. Huge exercise. This equipment here is making parts for that exercise, which again is really, really exciting to see. So that's Linotyper in AM Village, and I'm talking a lot, so I'll let Matt talk about what he was doing in Hawaii.
Go back just 1 slide first, real quick. It's a good to point out here. So Calum was 1 more. So those parts there, the one on the left is right out of the printer, and the one on the right is a full machine job, right? So you're looking at various stages of you could do various stages of complete, right? What's good enough to get you back in the fight fastest, right? So I just wanted to point that out. You can jump to my my next slide there. All right, so I just got back from Hawaii last week. We started with an exercise called Salvage X. Right, we're gonna be doing back-to-back exercises in Hawaii over the next 3 months. Salvage X, Trident Warrior, and RIMPAC. And we were out there for Salvage X this last week on Ford Island, Pearl Harbor, and you can see that pink-looking building behind. That's actually the former USS Tarawa. And what they're going to do for that is they're going to, first off, this last week we brought in reservists, right, from all over the country, and they do ground school to figure out how to use the equipment. So this week, over 2 or 3 days, they did a ground school, hands-on equipment, printing some parts. Next week, they're gonna haul that USS Tara out to sea, and they're gonna detonate C4 throughout a bunch of spaces on the inside. Then they're going to tow it back in, and they're going to use Additive Manufacturing, of which we'll be there with our EMU unit, the Expeditionary Manufacturing units, which is the speed cell and the X-Speed. And we're gonna attempt to save the ship, right? With advanced manufacturing methods that are on hand right there. And I think it's really the first exercise where I've ever seen advanced manufacturing be used to literally in real time save something, right? And save potentially sailors in a simulated environment where it could be at sea, and you've got to get the ship working enough to get it back into port, And so over the next 3 weeks, we're gonna go ahead and figure out how we can do that. Printing parts, designing parts, right, real time, and putting them out, machining them on site, and installing them, and save the ship and prove the capability. And then we're going to pick that up. And I actually will say last week I mentioned the monsoon conditions. It was raining 10 inches over 2 days, right? 2.5 days, and we printed the whole time, right? Changing powders out and didn't have any issues. So at the conclusion of Salvage X, we're going to go ahead and pick up the machine, throw it on the back of a truck, and drive it to the other side of the island to Marine Corps Station Kaneohe Bay. And it's going to be at, I think, Mal's 214 over there. And we're going to support Trident Warrior, which is the test side of RIMPAC. And NAVSEA is going to provide us real important Navy parts that they need solutions for, and we're going to print them up, and they're going to install them. Now they likely won't run them, but then after they're installed and we can prove they fit, then they're going to take them out and then hydrostatically test them to make sure that they meet the Navy standard. And then we're going to move on to RIMPAC, and RIMPAC will be a little bit more of the same, but with the potential to do more real-time solutions, right? So as folks come in with an RFF, let's call it like an RFF for request for forces. It'll be a request for a part, and we'll have to mark it up and see if we can print it and produce it in a timely manner and get it back out into the field. And it'll be a real opportunity to demonstrate the flexibility of the machine and how quickly it can operate and get parts back into the field. And that'll take us for the next 3 months.
Are you out there for the next 3 months in Hawaii, Matt? Is that what you're telling me?
I'm going to be bouncing back and forth. I'm back in Texas right now, but I was in Hawaii last week, and
Matt gets to go from Texas to Hawaii, and I'm here in Scotland in May in the rain. That's. I
told you I was in the rain in Hawaii for a couple of days. I mean, then it was nice.
The surf must have been awful. Julie, if we go back one slide, because Matt mentioned, back one slide, please. Matt mentioned EMU. Forward one, I'm just going to talk about EMU whilst it's in my mind. The slide on the right there, EMU, Expeditionary Manufacturing Unit. We talked about post-processing and how we want to be, SPEE3D want to be able to provide the full solution. So that's Expeditionary Manufacturing Unit, EMU. On the right of that image there, you'll see the printer. But on the left, we have speed cell. That's where you do your heat treatment That's where you do your CNCing, and that's where you do your testing on the bench space. Together, that's EMU, and that's about providing capability and not just technology. Defence doesn't buy technology, it buys capability. It needs an all-round solution that provides them a part. Why is it capability? Because they're able to test their products and provide data that the part they've made meets a standard that the commander is happy with to allow themselves to use that part. Okay? Without that, it's just technology. So that's EMU. I know Julie will be thrilled that I've spoken about it because we launched it last week. But we can move Julie forward 2 slides now, please. And we're going to take a very, very quick pivot before we do questions. SPEE3D, obviously, we like to think we do a very good job of expeditionary manufacturing. We talk about it a lot, we show our products a lot, we sell them, and we're helping defence forces make equipment to get more kit in the fight. But actually, cold spray offers you a huge opportunity to do so much more, particularly when it comes to the powder metallurgy. Okay, so the idea being that you can develop complex alloys by mixing metal powders, spraying them, and then when you're looking to make your alloy and get your metal properties, you focus on the heat treatment. And the heat treatment allows you to get some really cool material properties for some really complex alloys. Rather than relying on a complex, difficult casting process, where foundries are closing, institutional knowledge is leaving us, and casting is actually quite unreliable and very difficult. The automation and reliability of our process with our software allows us to print with reliability and then go through a heat treatment, which provides a consistent result time and time again. We've done that this year. Again, this is open source with a contract from NAVC, developing 2 particular metals for them, 2 complex copper alloy systems, a copper nickel and an aluminium bronze. They're complex industrial alloys. We have simplified the route to making them, whilst outperforming the defence standard, going beyond the UTS that's set in the defence standard. As a result of that, we've been able to make a light version of one of them, the nickel aluminium bronze. That will be launched at Rapid. So that's a Rapid nickel aluminium bronze at 390 MPa, allowing the maritime environment, like Salvex, like the US Navy, to make these nickel aluminium bronze parts. So that's a high corrosion resistant, self-lubricating, and strong metal parts. The opportunity to make alloys with cold spray in this manner is huge, and we're going to be doing that with lots of other countries later this year.
Hey, Calum, it's important to note. So those are the materials that the SubSafe program uses, which comprise 20% of a submarine. And so we're able to hit those metallurgical properties 100% accurately. And then also, Calum mentioned the light version. So the main versions of both of those, the copper nickel and the nickel aluminum bronze, require a HIP process. But we've got a light, we call it nickel aluminum bronze light, that does not require the HIP treatment. And so you get really, really close to those same qualities without the time and the cost of the HIP. And so it's a super cool, super tough material that I think is going to be very popular.
All right. I think
I saw one question in there in the questions, Calum, already.
Yep, that's the last slide. That's our speaking part done. There's another keeping you up to speed webinar later in June. And as you can see there, if you come along to that, you will learn again something new about SPEE3D. So not repeating the same stuff, but learn something new, in particular about our new large format printer, Titan Speed. Titan by name, Titan by nature. This is a completely different ballgame for SPEE3D. And you can see Matt and myself, the contact details for us both at the bottom of the screen. I haven't been looking at the chat or the Q&A. I should have said, if you have questions, please put them in the Q&A. I forgot to mention that at the start.
I see one in there. It's in the field. What was the power supply used? You can go ahead and you can answer for Europe first, and then I can split up for what we were in the US.
Yeah, so if you have speed cell and X speed together, you will need a 100 kVA generator, and generally you'll need an 80 amp socket. And that gives you plenty of space with that 100 kVA generator. 100 kVA is generous, you don't quite use all. In fact, it's more like 86, I think, kVA is what we draw across both. So it's not quite your average military generator. It's more like the theatre entry standard generators that militaries carry around with them. So the larger ones for larger footprints.
Yeah, it's a little bit more complicated in the US sometimes. We're using a generator in Hawaii right now, but sometimes we've got to use a step up or step down transformer, depending on which power source we're using. So, but we haven't had any real issues on base. We're always able to power it up.
If anyone has a question they want to ask rather than type, then please feel free to unmute yourself and ask a question. Otherwise, we've done a sterling job, Matt and I, which I can't believe.
Hey, Matt and Calum, this is great. This is Clint. I appreciate you answering that question. Just a follow on to that, and maybe this is something that you guys are going to be working on, Matt, with your, Salvage X, Trident Warrior, and Rim Pack coming up. I sounds like the ultimate goal is to have the EMU on ship probably at some point. Is there already built-in safety and security in the EMU that obviously you're working on ship power, and that can be dirty power, or you might have power surges, that sort of thing, or even in this scenario, maybe no power at all on the ship. Maybe you can kind of talk to that.
So I kind of see it from the Navy side. It's not going to go on your classic destroyer type ships, right? It's likely going to go on like an LHA or an LHD, or even one of our supply ships. And we haven't worked through everything yet right now. I mean, it's going to plug into ship's power. But I think it's also prudent to have a generator. And if it's on the amphibs, there's going to be, the Marine Corps is going to have that capability there. So if you are in a dirty power situation, or you've got power fluctuations, or you're in a denied environment, you can hook up that generator and you can run it in the well deck or on the flight deck, and not worry about it, right? And we're not worried about the generator throwing out fumes. So there's a lot of options with this, right? Because you can use either the ship power or the generator power. And also, we've just come out with our explosive data sheets, and we've taken all of our materials and had them test. And I think the most explosive one tested somewhere along the lines of a little bit less than powdered cornstarch and a little bit more than belly button lint. So they're safe to go on ship. Those powders are all safe to go on ship.
Okay, I like that, Matt. Yeah, having served almost a year at sea on an LPD, I think I like that option of down in the well depth with the Marines and not up topside with the Navy guys.
Right on.
It's also worth noting, if you did lose power, that's not catastrophic to your print. Okay, it's not ideal for a printer. We don't like losing power to the printer because we cool elements of the printer, but it doesn't harm your print. So once the printer's back online, you can pick up where you left off.
Okay.
Which is really exciting. And again, there's no powder bed. There's no bed of powder that we need to worry about keeping level. We have done a little bit of printing on the water, not at sea, but rather alongside. And we were able to print regularly, reliably, one time after the other. It wasn't a heavy sea state, right? You're in port.
Yeah.
But that in itself, I won't say it was easy, but we had no printing issues. Yeah. So there's a bit of discovery there. Just what sea state can we print in? How far can we go?
There's another question out there of what the size of the speed cell is, and they're both the speed cell and the X-Speed are 20-foot containers.
Yeah. So they sit in the back of any truck. One truck can pull the entire capability with a a bed and a trailer behind it.
This is Quentin. I'm more interested on the front end of the process, and maybe this isn't a question for this discussion, but just as far as these technical packages that you release, what are you recommending for, like, one on the personnel side as far as having a handle of CAD software and the software used to run your machines, whether it's a repair part or a brand new part? I was just kind of curious how you recommend working through all the front end to then get a part to print.
Yeah, okay. It's a good question. And if I focus on when we work with soldiers, sailors, and airmen, we coach them. Generally, we will have a partnership. We'll call it a partnership. We're going to hold their hand for a couple of years because basically we're developing a new capability. The military do not have fabricators, manufacturers. We have outsourced that for far too long. And we are bringing this new value prop to defense, saying, if you had the technology and if your people were suitably swept, you could be doing this. Here's the technology. But the next part is the people. And they aren't qualified yet. And so we are having to coach them and bring them along, one soldier, sailor, airman at a time. And we're really taking them back to basics. They are not, it is not to be the case that someone comes up to them and goes and puts a part in front of them. I need you to make that for me. Incorrect. That customer is asking them to solve a problem, to get a system back online, to get a platform back online, not replicate the part. The soldier, the manufacturer, needs to have an appreciation of the system they're making a part for. So they're going to have to see that platform, understand it, empathize with the problem, and then design a solution. It might look identical to the part they already have. It could look very different and often does. When it comes to measuring and designing, we tell them never to rely on a digital file because militaries don't have digital files or give them out. They're terrible for it, or OEMs are really difficult to get these files for. Rather, get your calipers out, start measuring, start designing. You know, our team, okay, we're experienced in this, but we can design a part in half an hour. Run the simulation for 30, 45 minutes thereafter and have the print file ready to go. So in a couple of hours, you've got your print file ready to go when you have a suitably capable manufacturer. So that's the approach we take when it comes to the deployed solution. Okay, you can do this on any, like I said, SolidWorks, Fusion 360, whatever software. That's not the constraint. The constraint is the capability of the individual. And we are just taking up one soldier, sailor, airman at a time, until such time that these organizations realize, man, there's a great opportunity here. We need to upskill our people in the way of digital manufacturing and digital skills. And right now, generally, it seems across the board, all nations are pretty poor in that regard.
Yeah, I really appreciate that answer, and we fully agree. We've seen that too, and yeah, just the training of the personnel and everything. So, but have they been pretty excited about it? I mean, when they see it and kind of what you described earlier of actually seeing the parts, have they been pretty open to the adoption of all this?
Great question. You can tell within 20 minutes who's going to be successful and who's not. If they are not excited by the proposition of getting their hands on this kit and developing their own skills in this way, you've got the wrong person. The ones who are in your face, immediately asking questions, wanting to learn from the get-go, you know you've got success right there, and you just need to invest time in them. And when we've done that, we've created some really exceptional manufacturers inside defense, which terrifies defense as well, because what's that soldier now? They're valuable, not just inside defense, but also outside. And so, you know, there's only so much you can upskill these people before they start realizing their value and start looking perhaps to the outside. This is why defense needs to start doing this, to create the correct career profile for these manufacturers to incentivize them to stay in, upskill them, and keep them in the organization.
Yep. Great. Thank you very much.
Hey, Calum, I think I saw one quick question. I don't see it anymore, but it was they were talking about temperature ranges, and so I thought I'd just hit the whole thing real quick. So we've tested the printer, in the tropics, 100 degrees plus in the desert, in a sea environment. I won't say at sea, but next to the ocean, and then obviously in the rain, tropical rain, downpours, and then also we've operated the machine for 3 days in -20 at the Army Krell facility in New Hampshire. And so it was 3 days operating the machine at -20, and we were able to continually print.
Excellent. Well, everyone, I think that's probably a good time because we're 45 minutes into a 30-minute webinar, and I really appreciate those of you that have stuck with us and asking questions and making Matt and I, well, we've enjoyed this. I've really enjoyed this, and thank you for staying around. You can see our contact details there. If you would like to learn more about SPEE3D, I would say you have our details there, but we also have a really smart YouTube channel, which will bring to light far more than Matt and I ever could with video, how it all works. Okay. And then seeing is believing naturally. So if you ever want an opportunity to see a printer working in person, then you have our details there. Just give us a shout. But Matt, unless you have anything else, I'd say we give it another 20 seconds, and then I'll wish everyone a happy Wednesday. It is Wednesday. Happy Wednesday.